Alright guys, we're going to try a remote lab today, and we're going to be looking at friction force, and we're going to be involving basically a 0.5 kilogram weight that we're going to be sliding across 4 different surfaces. First one is going to be 320 grain sandpaper, the next one is going to be industrial carpet, and the third will be pretty coarse sand, and then the fifth will just be plastic, and in this case a plastic tray. So what we're going to be doing today is utilizing the GLX, in which we're going to slide basically this weight across this surface, the 4 surfaces, and then we're going to measure that force, and from that force be able to calculate the coefficient of friction. And from there we're going to see if we can do some type of internet research, which will be up to you guys, to do a comparison between the calculated / measured coefficient of kinetic friction to that of what would be stated, say, within a coefficient of friction table for different types of material. And this is pretty interesting from the aspect of lots of considerations that we have to think of for not only the type of surface that we're pulling our weight against, but also the weight itself, and maybe how the weight itself could affect that coefficient of friction. So let's talk about friction forces in general anyway. So what we're going to be doing is looking at a very, very simple free body diagram here today. So obviously mg, that's just basically the force of gravity pulling down onto our weight. That's going to be 0.5 kilograms times 9.8 meters per second squared. And here we get that to be actually for a normal force being 4.9 newtons. Now, everything about the friction force is dependent upon the normal force. In fact, actually, the coefficient of friction, all that does is give us basically a proportion of that normal force that actually occurs once we actually start sliding in basically positive motion for basically the block to go to the right, and that tension force has to equal basically to this friction force, which is mu k times Fn. And so what we're going to do is take basically Fn, we're going to basically divide that through by our friction force, and then easily be able to come up with a coefficient of kinetic friction from there. So what I'm going to do is I'm going to re-angle this camera, and I'm going to, utilizing the GLX, I'm going to slide each of these weights across the tables here, or across the surfaces, and tell you guys what that force, that friction force would actually be. And then from there, I'm going to have you guys go through and then calculate the coefficient of kinetic friction, and then you're going to compare that to some value you find on the internet. And then from there, you guys will just send that to me and put it into the Dropbox I'll make for this class in eLearn, and we'll be done. So let's take a look. We're going to do 4 surfaces. So I'm going to maneuver the camera back around this way. All right, so as you guys can see right here, I got 4 different surfaces. I got 320 grain sandpaper right here. I got some industrial carpet, some coarse sand, and then also basically regular plastic tray. So from here, guys, what we're going to do is basically just pull these directly back at a very, very 0-degree angle. Because if we pull at an angle, it's the #1 mistake that people make within this lab. If we pull at an angle, then we're actually changing the normal force, and we don't want to do that. So I'm going to start off with the 320 sandpaper, and I'm going to pull this back at a very, very consistent angle, and I'm going to tell you guys exactly what force I'm reading. And after I get done telling you these forces, I'm actually going to show you guys what it looks like on the GLX. Alright, so I'm going to press play using our force meter here, and pull this consistently. And that is reading about 3 newtons. Alright, so the friction force, and obviously that's basically the opposite of the force that I'm pulling it at, is actually just going to be 3 newtons. And let's see if we can get a measurement across the carpet. Ooh. All right, let's see what we can get from here. Say, okay, so the sandpaper was 3. Let's see what we get for carpet. Okay, so this one, I get about 2.5 newtons for the friction force. All right, so that was 2.5 newtons for the carpet. And let's see what we get for sand. Now this is just regular old coarse sand. It's not fine or anything like that. Same stuff that you would basically find on the beach. All right, so let's see what we get here. So for this one, let me try this again. That didn't seem to work really well. I'd say probably around 2 newtons. So rough guesstimate right there, 2 newtons. All right, so now I'm going to pull this across our plastic. And hopefully we get some pretty consistent data on this one. And this one, I get 1.5 for the plastic as far as the friction force. So here we had basically the friction forces that we measured with the GLX for our plastic tray, coarse sand, and then for the industrial carpet, and then the 320 grit sandpaper. So what you guys will do is simply take that friction force, divide that by the normal force of the weight, which is just simply 0.5 times 9.8 meters per second squared, and then take that calculated coefficient of kinetic friction, and then what I want you guys to do is from here, look that up on the internet, look up material coefficients for friction within Google, or you can even say the specific material itself. So you can say carpet, or you can say plastic or sandpaper, maybe coefficient of friction for sandpaper, and see if you can do a comparison between your calculated value of the coefficient of friction to what you may see within a table. And so do that, and then from there, guys, just shoot me your calculations and your work, and tell me what you guys think. Did you make a good comparison? Were you able to find the coefficient of friction? Let me know, and we'll call it good for this one. All right, I'll see you guys next week.